Hi Dragons, function notation. Let's go. Function notation is a different way of writing y equals mx plus b. So sometimes we use the letter F for function, or G or H, or in this example we're going to use a D later on. It helps describe the situation. So the function f parentheses x, we read it as f of x, where x is the input. So if we consider our familiar equation y equals 8x plus 15, and we say that x represents the number of shirts we're going to order from a company, and y represents the cost of the order. Let's consider that for our examples. The equation can be written using function notation. So I want y'all to notice that the y equals 8x plus 15 and the f of x equals 8x plus 15, the only differences are the left-hand sides. The y has been replaced with function notation. Now, I need for y'all to remember that this is not f times x. We're not bringing in another variable. Oh Lord, no, not another variable. This is a function of x. What is the process in each of these? Multiply by 8, add 15. So the cost of the shirts is going to depend on how many I order. And when we actually crunch numbers for an order, it's called evaluating a function. So let's look at an example. The cost of ordering 4 shirts can be calculated by evaluating the function when x equals 4. So we're going to write this as f of 4, f parentheses 4. This is not f times 4, okay? So we're going to substitute 4 in for x in our rule, okay? So let's do that. Let's put a 4 in here and a 4 in on the other side. So now the function at 4 is equal to 8 times 4 plus 15. 8 times 4 is 32. 32 plus 15 is 47. So my input of 4, remember the input is the x, gave me an output of 47. Oh, I need for you to recognize when you see something like this, it's just an ordered pair. It's just an input and output. See that? If I give you a problem that looks like this, you need to be able to say, oh, my input was 4 into the function, and my output was a 47. So again, y equals mx plus b. It's just going to be rewritten in function notation. Okay? And this is going to help you out as you go to different functions other than lines later on in your mathematical career. So as we look at some of these problems now, we're using the same shirt order rule. This is our function. The domain and range, what do they represent? Well, remember the domain is your x's or your inputs, and your range is your y's or your outputs. The x's from above represented what? The number of shirts. So the domain is the number of shirts that you order, and y is how much it cost. Okay? So let's do some more problems dealing with shirt orders. First thing I need for you to do is scratch out this little s. I forgot to take it out. My function is still 8 times x plus 15. All right, so here we go. In this particular case, the function has an input. Remember, whatever is in the parentheses is your input. So my x is 7. So over here, what do I do with every x? I multiply it by 8, add 15. So 8 times 7 plus 15. So let's crunch the numbers on the right-hand side. That's 56 plus 15, and that is 71. Okay? So what does it mean? It means that if I have an order of 7 shirts, it's going to cost me $71. Okay? So 7 shirts means $71. That's what it means. Okay? Let's do another one. How many am I ordering here? Well, this is my input, this is my x, and x represents the number of shirts. I'm ordering 100 shirts. Okay, how do we calculate the cost? How does the function tell me what I owe? Well, multiply by 8, add 15. Okay? So the function, when x is 100, is going to produce 8 times 100 plus 15. So that's going to be 800 plus 15, which is 815. What does it mean? 100 shirts ordered means that I'm going to have to pay $115. Okay. Now, you're going to finish doing the other one as prompted by Ed Puzzle. All right, let's look down here. This is going to reverse the process. Up here, we knew how many shirts we were ordering. In this problem, we don't know how many shirts we're ordering, but we do know that it's going to cost me $55 because this is what the function produces. So we're not going to multiply this by 8 and add 15. No. Okay? This is the output. So I don't know my input. So here's what we're going to do. We're going to take the function, which is 8 times x plus 15, and we're going to write it underneath the function notation because that's what it is. The function is 8x plus 15. And the output produced here is 55. Does this look familiar? I hope so. That's a two-step process. So subtract 15, making zeros and ones. Get 8x is equal to 40. And there's my 1. 40 divided by 8. X equals 5. Oh, well, that makes sense. 5 X's, or 5 shirts, is going to cost me $55. Okay? So the process is reversed. When you know the X, when you know the input, okay, you're going to evaluate. You're going to use PEMDAS. Okay? When you know the output, you're going to solve an equation. Okay? So they're not the same procedure. Okay? Now, quickly on the back should be easy because all you're going to do is look. You're going to look at the table, at the inputs and outputs. All right? So here's my inputs. This used to be my X column. This used to be my Y column. What did they name this? They named it H. Why do you think they named it H? Oh, because we're talking height. All right. So A represents age. Oh, so makes sense. A is the age, and H is the function. And you got to have age before you have height. A, and this is H of A. This is not H times A. No. Okay. So 7, is that an input or an output? Well, it's in the parentheses in the function notation, so this is my input. So I'm going to look in the first column for a 7. Oh, it's right there. I just look, and it goes to 49. So what does that mean? That means that an age 7 boy is typically 49 inches in height. Ordered pair, input, output. Okay? Don't let them trick you on this. 1.5 years is 18 months. Okay, so we look on the chart for 18 months. And if they ask you to estimate, just give it a good guess. And again, down here, they're going to reverse the process. Notice inside here, I don't know the age, but I do know the output. The output is the height. So over here, I'm looking for 61 in the output column. Just look to your left. Oh, that's 13 years old. So in this particular case, the age is going to be 13. So a 13-year-old boy is typically 61 inches tall because the function, the output, was 61. So I look in the second column. Okay? Just real quickly on this last one, you're just going to be gathering points from the grid. Okay, same thing. We've got time and we have distance. You notice that they don't call this the y-axis, they call it the d-axis because it's talking about distance. So this function, distance, depends upon the time travel. okay? So they call it a function d, because we're talking about distance. Makes sense. So over here, we have d of 2. 2 is an input, so 2 is the time. So I look down here at 2, go up to my graph, and then say, all right, how far do I get? So I look over here on the distance, and I go, oh, that's 4 miles. So 2 hours of travel gives me 4 miles of travel. Okay, so d of 2 is equal to 4. And if we interpret that, it's 2 hours equals 4 miles. Down here, we're going to reverse the process. Notice the function gives me an output of 2. So now I'm going to go look on the output at 2, go back to my graph, and then come down. So that gives me a time of 1. So in this particular case, my time is 1 hour. 1 hour gives me 2 miles of travel.